You may have heard about the International Space Station in low Earth orbit at about 400 km above the Earth's surface. I have covered many topics in previous episodes. This space station is due to retire in 2030, with of course possible extensions to that date, using a modified SpaceX Dragon capsule to safely and accurately deorbit it to further burn into the atmosphere and for the rest to be buried in the southern Pacific Ocean. So, what's next for NASA and the rest of its international partners with space stations? What is clear is that NASA is promoting more and more commercial partnership which have several benefits, for example, reduce NASA upfront development costs and amortize it during use, as we have seen with SpaceX Dragon, for example. I will explain in this episode which are these private partners involved in building space stations. But before I go there, and to be more accurate, NASA is already busy dealing with a space station not in low Earth orbit, but rather in low Moon orbit, well, actually in an elliptical orbit to be precise. It is called the Lunar Gateway, which will allow international astronauts to stay there to live, to work, and carry out experiments, but also reach the surface of the Moon and depart to Mars from there. Many companies are contributing to this project, including a couple of European companies. Thales Alenia is developing the airlock module called Lunar iHab, including living areas and docking ports. Additionally, Thales Alenia has been contracted by ESA to build the European system providing refueling, infrastructure and telecommunications called ESPRIT to provide refueling through xenon and hydrazine for ion engine and hydrazine thrusters, as well as additional communication equipment, a habitation area and storage. The Habitation and Logistic Outposts, or HALO in short, is under Northrop Grumman's responsibility. However, several parts are being manufactured and tested by the European companies Thales Alenia and Airbus. You may say, why not focus on the Lunar Gateway and not bother with the replacement of the International Space Station? Well, you may be right, but it is quite a hardship to actually fly to the moon. It requires huge rockets to get there with the current technology and therefore costs quite a lot. To put things into perspective, a NASA SLS rocket launch to the Lunar Gateway cost about $4 billion, whilst a SpaceX Dragon launch to the International Space Station costs between 220 million to 350 million, so 12 to 20 times less. Many projects are already in the making. NASA is funding 3 companies to replace the ISS American modules under the Commercial Low Earth Orbit Development Program. It first started with Axiom Space to design the first modules to be connected temporarily to the ISS and grow from there. It contains living spaces for the first 2 modules with a large cupola expected to be delivered in 2025 and 26, and a laboratory and manufacturing module to be delivered thereafter. It shall also include a flexible logistic arm to modify the various station module configurations. The 4th module will be what they call the power tower to allow the Axiom station to be self-sufficient with power generation and thermal heat rejection. At which point, the Axiom station will separate from the ISS and run solo. They intend to run the station with professional astronauts and prepare the visitors through their existing facility, as we have seen with Axiom 1, 2, and even 3 missions in the past years. Axiom is not working alone on this project. In fact, the European company Thales Alenia Space is building the pressurized modules for the first 2 modules, including the pressure vessels and debris protection systems. The next company selected by NASA is Voyager Space, working on a private space station for tourism as well as for research and manufacturing. They anticipate building a single module containing living space, laboratory, and power unit, expected to be launched in early 2028 by a SpaceX Starship. To put things into perspective, the Star Lab is about 340 cubic meters of internal volume for a crew of 4 astronauts in a single module, to be compared with the ISS hosting up to 7 astronauts in a space of 916 cubic meters, so about 3 times more volume, but it took 42 launches to assemble the ISS, so huge progress has been made since. Voyager Space had partnered with Airbus, Mitsubishi Corporations, and MDA Space in the joint venture Starlab Space. The consortium is responsible for designing, building, and operating the Starlab commercial space station. They have also teamed up with Northrop Grumman to resupply the station with the Cygnus spacecraft. Incidentally, Northrop Grumman was originally planning to build his own space station, but instead decided to join forces with Starlab Space. That change also put Lockheed Martin off, which left the original consortium. That joint venture is endorsed by ESA through a Memorandum of Understanding to allow ESA astronauts' presence in space after the ISS retirement. To strengthen the ESA ties, Airbus and Voyager Space opened Starlab Space Europe with facilities in Bremen in Germany. This branch aims to enhance the company's global collaboration in microgravity research and low Earth orbit commercial activities. This is the only direct European space station involvement in low Earth orbit. The last contract award from NASA went to Blue Origin, which partnered with Sierra Space and Boeing to build the Orbital Reef, aimed to start in 2027. Blue Origin leads the project and manages the large central sections, while Sierra Space is building the inflatable modules, along with the crewed and cargo spacecraft called Dream Chaser. As for Boeing, they are providing station operations, maintenance, and the Starliner crew capsule. There are other partners such as Redwire and Genesis Engineering in charge of payloads and specialized equipment. Blue Origin does not advertise too much on progress in the best of time, so we have not got a huge amount of information on the orbital reef. However, Sierra Space is, and I have covered their progress in many previous episodes. The Dream Chaser number 1 has been fully manufactured and tested and is ready for launch on a New Glenn rocket around the summer of 2025. As for the inflatable module, it is called the Life module. It has been extensively tested for leaks and maximum pressure, and a flying hardware is being manufactured as we speak. No date for launch has been made available just yet. Then we have VAST, a newly formed American company just 4 years ago, not supported by the NASA Commercial Low Earth Orbit Development Program, but aiming at delivering a space station demonstrator called Haven 1. Their aim is to show NASA how advanced they are and motivate them to fund the rest of the project, with this Haven 2 concept, a modular space station. Interestingly enough, the shape of the Haven 1 module is tapered at one end to maximize the room inside Falcon 9 fairings. It is interesting to see how the station design is driven by a rocket fairing. Each module can operate independently as a free flyer, meaning it does not need robotic arms or spacecraft to move the modules around thanks to thrusters. They are starting with 3.8 meter diameter modules driven by Falcon 9 fairing size and will move towards a 7 meter diameter modules once the SpaceX Starship is entering into service. The Haven 1 structure has already been manufactured and even tested. FAST is now moving quickly towards building the flying version for a launch in May 2026 at the earliest by a SpaceX Falcon 9 rocket. China did not want to join in this international space endeavor and went alone by building the Tiangong space station stationed around 400 km altitude. So far, 3 modules have been assembled in orbit between 2021 and 2022. In 2026, CNSA anticipates sending another module to join the Tiangong called Xuntian, a space telescope module. Obviously, this space station is rather new and can operate for a good 20 to 30 years more. India is also working on its Bharatya Antariksha Station, sorry for the pronunciation, meaning Indian Orbital Space Station, made of 4 modules expected to orbit around 400 km altitude, led by ISRO. They anticipate launching these modules starting from 2028 up until 2035. In fact, ISRO is working on a new rocket called Surya, or Next Generation Launch Vehicle, to launch the larger modules. India has been working on its crewed capsule called Gaganyaan and even tested its docking hardware in space a few weeks ago. Russia is also building the Russian Orbital Service Station with the ambition of getting it ready by 2030, with the first 4 modules after the ISS retirement and up to 7 modules by 2035. They have worked on several concepts where you could see one of them. Interestingly, they plan to use a sun synchronous orbit, meaning the station will constantly be exposed to the sun, perfect for the power generation but less for sun radiation, with the advantage to study the Arctic region. They also mentioned that the station will have a module dedicated for space tourism, able to accommodate up to 4 residents. Roscosmos also envisaged a partnership with a consortium from the governments of Brazil, India, China, and South Africa, known as the BRICS, to financially support the Russian orbital service station. However, very little is made available in the public domain, so maybe it will happen, maybe not, time will tell. So, space still attracts many interests, and a vibrant economy is gradually developing from these private companies. Well, perhaps the cost of space will become affordable in the next 20 to 30 years, that you and I could go in space. Well, luckily, it costs nothing to dream. Thank you for watching your channel all about space. See you at the next episode of Space News.